Good day, Professor Romero Angeles. My name is Nicolas Guin Perez, and I will present my final project, a TPM-based continuous improvement plan for the Kenworth chassis line. This study analyzed the administrative and operational framework of Kenworth Packard Mexico, located in Mexicali, Baja California. To begin with the introduction, Kenworth Packard Mexico is a cornerstone of heavy-duty manufacturing. Because of physical access restriction to the plant, this project was developed as a theoretical desktop analyzing using reverse engineering. The main objective is to identify theoretical areas of opportunity with, between the chassis assembly line and design an operational reliability proposal based on TPM. Specifically, the focuses on the autonomous maintenance pillar to reduce the tool wear, eliminate micro downtime, and keep a continuous production flow. Moving on the development phase, we start with a planning. The core goal here was to design a practical, standardized guide using the TPM methodology. This guide is specifically for the frame assemble area to prevent unscheduled downtime caused by the tool wear or invisible deterioration. To achieve this, the research strategy involved gathering information from industrial layouts, automotive manuals, and corporate sustainability reports. Finally, as you can see in the figure 1, a Gantt chart was used to control our time across 6 critical stages, start, starting for the initial context mapping on May 12 to the final submission on the May 17. The next phase of the administrative process is organizing. Since this is an individual engineering project, the organizational structure is linear and direct. Through reverse engineering, a simplified process mapping was established to understand the division of labor and sequential workflow between the chassis line. First, station 1, which you can see in the figure 2, we have the side rail receiving and positioning. This is where the basic structure and alignment to the high strength steel beams take place. Right after, at the station 2, shows in the figure 3, the cross member assembly and riveting are performed. This stage is critical for securing the torsional rigid of the heavy-duty truck using pneumatic and hydraulic fastening tools. Continuing with organizing, we have the final two stages of the chassis workflow. At the stage 3, shows in the figure 4, we see the suspension and axle mechanical dressing, where the heavy-duty lower components are integrated. Then, in the station 4, represents the cab to chassis marriage and integration, visible in the figure 5, which is the final stage where the motorized cab is mated onto the frame mounts. Based on the process, our theoretical problem diagnosis shows that since Kenworth Mexicali is a world-class plant, the main risk is not physical mess, but the tool fatigue and calibration drift is a critical station. If a bottleneck tool or hoist fails mid-shift, it directly alters the stabilized takt time and stops the entire downstream production sequence. Now, let's look at direction and controlling. For direction, implementing this proposal requires supportive leadership. Management will focus on empowering operators with a physical sense of ownership, promoting the philosophy this is my equipment, I care for it. Leadership will act as a facilitators to guarantee technical resource under a Kaizen or continuous improvement culture. For controlling, we propose tracking overall equipment effectiveness. known as a OEE, focusing specifically on tooling availability, availability as a corrective action. If an operator detects an anomaly during the pre-shift inspection, they will deploy a red TPM tag on the station and shows in the Fury 6. This trigger an immediate request for the maintenance department to intervene before a catastrophic asset failure happens. Finally, let's address human resource management and our conclusion. For human resource, the strategy includes 2 hours of technical onboarding workshop for floor personnel focused, focused on a proactive defect detection. Also, clear accountability is established for by formally allocating, allocating the first 5 minutes of each shift for operators to execute a mandatory autonomous maintenance routine. This checklist includes a technical cleaning, lubrication, and visual calibration. In conclusion, this project demonstrates that industry engineering principles deliver significant corporate value even through remote desktop research. Implementing this TPM guide prevents mechanical failure in critical chassis stalling, maximize assemble availability, availability, and ensures that Kenworth Mexicali continues to manufacturing under the highest standards of global competitiveness. Thank you very much for your time and your attention.